Hello everyone. Good evening and welcome to another TS section of our course, Data Science for Engineers. So in this section, we'll be discussing the last topics of our course, that is K nearest neighbor and K means clustering. Right. So let's start our section today. So what is a K nearest neighbor or a KNN? So it's a classification algorithm that operates on, it's a very simple principle, like a distance function is used. So we'll see what exactly it is. So it's an K nearest neighbor. It's a classification algorithm. It's also a supervised machine learning algorithm. Even though it is mainly used for classification purpose, it can be used for regression tasks also. So if somebody asks a question like, is K nearest neighbor can be used for regression, you have to say that it can be used for regression also. So it's like the basic idea behind a K nearest neighbor is like similar things exist close to each other, so that like when we put everything in a feature space, so if different data is placed in a feature space like a 2D or 3D space, so if two objects or two data points are having some similarity, they will be close to each other. So let's say for an example, so let's say imagine we have an imaginary data on dogs and horses, having data, two features are heights and weights. Okay, so it will have a two-dimensional feature space. So this is how the dogs and horses will be placed in the feature space. We know that horse will be usually higher than dogs. So if you see like the height chart, the horses, dogs are always below this line, and horses are above this line. So what we need is some algorithm to distinguish between these horses and dogs if only height and weight is given. So based on the height and weight, a point can be placed here or here or here. So a new data point, if you get like if the features are just the height and weight, if our model is already trained, we will have some representation of how the data are distributed in the feature space. So easily we can classify this as a horse or this one as a dog. And this point, how we will classify that. So we'll see how it will be done in the later slides. So the training algorithm is like store all the data. Like if we give the data, they will use the distance metrics to calculate the mm, different clusters or different neighbors in the available data. Then how can we predict when we have a new data set is given or new data point is there? So let's see that. So while training a model, we have to store all the data. So all the data will be stored in our machine. And once a new data point is introduced, we calculate, let's say X is the new data point we have. Then we will calculate the distance from X to all points in your data. So let's say we had our um, host data and we had our dogs here. So let's say a new data point is upon data point X is there. So once X is placed somewhere here, it will calculate the distance to all points in your data. And it will sort the points in our data in an increasing order from our X in like the distance. So if we sort our data, so in this example, the let's say this is 1, 2, 3, then we have 4, 5, 6. So in this example, if you write, the distance will be sorted like 1, then 3, 2, and we will have 6, then maybe 4, then 5. So this will be the order by which the data will be sorted, the distance will be sorted. Now what our model does is we have to give the number k to the model. That is how many nearest neighbors it should consider. All right. So once the sorting is done, so let's say I choose 3 or let's say I choose 4. So if you choose 4, then we will take this 4 distance and see which class this belongs to. So from this figure, we know this is horse and this is a dog. So this point will be horse. Whereas if X was somewhere here and if we choose 4 again, so it will be like this. So we'll have 3 dogs and 1 horse distance. So this K determines how many closest points or closest neighbors we should consider when using this training, using the K nearest neighbor to predict the new dataset class. Now the same applies when it is here. So that was the third data point that we saw. So what the third data point will do? It will calculate the distance between all the points and it will sort, and depending on the number of the K number, so it can take either 3 or 4 or 5. Usually 3 or 5 are chosen. So let's see how choosing different Ks will affect different classes. Okay. So the star is the new data point that we want to predict. So choosing a K will affect what class a new data point is assigned to. So in this data set, we have 2 classes. So we have the class A, then class B. So we have 5 number of class A points and 5 number of class B points. So first, our new data point X, let's say it has X1, X2. So it is somewhere here placed, X1, X2. Now what it will do is first it has to calculate the distances between all the points. Okay. And then we have to decide what is the k number. So if k is equal to 3, the closest 3 data points are 1, 2, and 3. And among the 3, so among the 3, we have 1 of class A and 2 of class B. So if the k is equal to 3, we will assign the data to be class B. Whereas if k is equal to 6, now the nearest points are 1, 2, 3, 4, 5, and 6. So now we have 4A and 2B. And now the class will be A. So the choice of class also affect the classification result. Okay, so this was again the so choosing a k will definitely affect the new point. So in this case, we have more number of how different k will affect. So if k is equal to 1, we can see that uh, all these red areas, the red areas, wherever the new data set comes, it will be classified as a host. And if it is a blue area, if some points are coming to be in the blue area, it will be classified as um, dog. Whereas when the k is increased to 5, we can see that the patterns have changed. So earlier there were some patterns like some area where we can see the horses inside the dogs cluster. But when we move to k is equal to 5, those areas are missing. So this is the how the let's say the feature space is divided among the two classes when the number of nearest neighbors are increased and decreased. And again, if the k is increased to 10, it again changes. Then when k is changed to 50, we can see a clear separation. So it's almost like a straight line. Now, what are the some of the advantages of using k nearest neighbor? So when using k nearest neighbor, we can say that the code is kind of very minimal. So what we need to do is we just need to mm, find the distance. Then whenever new point is introduced, we just need to find the distance, sort it, and we have to find the who are which class is nearest to k, nearest to the introduced point. So the training is a trivial problem, so it's just a distance calculation, and it also works with any number of classes. So even if we say like we have 10 or 15 classes, there can be chances like there is a clash like whenever we take a k is equal to let's say 4, then we might end up with let's say 2 circle and 2x. So mostly the k is chosen to be an odd number so that this issue is mostly avoided. So whenever k is equal to 3, we will be choosing only 3 nearest neighbors so that in most of the cases we will be ending up with one of the majority classes. Now then we can add more data to our class. Then because we need to only find the distance, and we have only few parameters to consider, that is the number k and the distance metric. What kind of distance metric we have to use? So maybe we can use let's say, so if this is a point and this is our reference point. So there are a lot of methods to find the distance. So maybe we can use the Euclidean distance, that is the direct root of x1 minus x naught whole square plus y1 minus y naught whole square, or we can use the Manhattan distance. So in that case, we'll have the distance along these two directions, that is x1 minus x naught absolute value of that plus y1 minus y naught and absolute value of that. So we can choose different distance metric also to calculate the distance. So let's say what are some of the disadvantages. So the cost for prediction may be higher, or so let's say we have very large data set, and the k nearest neighbor algorithm works like that. So we need to find the distance between the new point and all the points in the data set. So that can be sometimes very expensive, and then we have to sort it, and all those steps has to be uh, repeated. Then it's not actually good with the high dimensional data. So now what we have seen is we had only x1 and x2. So we had only two dimensions describing our data. So when this number, when this features goes to, let's say, a higher number, then it may be difficult, or it may be computationally also expensive. Then categorical features does not work well. So mm, the distance functions and everything works well with the numerical data. So if you are to convert the categorical features into numerical and find the distance, um, mathematically or mathematically we can calculate that converting categorical numbers, but in physical sense it may not be a right approach. So we have some questions. Please try to answer.
Hello.
Yeah, please.
Yeah, it has been it has been used in statistical estimation and pattern recognition.
Um,
As first
if you,
one is true, it stores all the cases, right? Then
yeah,
it
it's true.
cannot be used for regression. That is also true. It The
No,
input consists of k closest training example in the feature space. वो तो रहते हैं.
this is true. This is true. So what about the third one? It says it cannot be used for regression. So in the beginning itself, I have
So,
mentioned even though KNN
so
is
the
an
answer is B.
actually the answer is C. B is also correct. Actually, the case is even though KNN is used for um, let's say classification mainly, but it can be used for regression also. I mentioned it in the beginning of the class itself. So how it is used for regression? So let's say, mm, so I will just give you an example. So if we have this, let these three be the neighbors. Let's say we have more points and we have a new point introduced. Then we'll find the again the distance and everything, and we'll find the k. So in regression, we know we have a value. So we have value to each data point. So let's say these three are the neighbors. Let's say k is equal to 3. Then what we do is we average the final value, or the regression value will be the output will be equal to the average of all these three neighbors, k neighbors. So the correct answer is C. What about the second question?
D, the output is the property value for the object.
B.
The output is the property
Yeah.
value for the
Yeah.
object.
Yeah, correct. D is the correct answer. So the explanation is like the KNN is used for both classification and regression. So in case of classification, the major class of the neighbors are chosen. Or in case of regression, we use the average value of the neighbors. And for the second question, which is not true. So yeah, the option D is the correct answer. The output is the property value of the object. Now we have a little bit long question. So we have data from a survey and objective testing with two attributes. So we have two attributes A and B to classify whether a special paper tissue is good or not. So here are four training samples given in the table. Now the factory produces a new paper tissue that pass laboratory test. So we have A is equal to 3 and B is equal to 7 for the new case. And if we choose K is equal to 3, then good is the classification of this new tissue. So how we will proceed? So this is actual data that we have. So let's say we have our data like A, B, then A is 2, 4, and 7. B is 4 and 6. So we have data points 7, 6, 7, 4, 4, 4, 4, and 2, 4. So this is the data that we have. So this is good. Then this is bad. So let's say this is bad and this is good. So now we have a new data, which is at B is equal to 7, B is equal to 7, and K A is equal to 3. So it will be somewhere here. So let's go step by step. So what we have to do first is we have to find the distance between the new data and the old data that we have. So what we need to do is we need to find in the first case we have to 7 minus 3 whole square, 7 minus A was 3, right? Okay. 4 minus 3 whole square, 2 minus 3 whole square. Then we need for 6 minus 7 whole square. Yeah, 4 minus 7 whole squares, whole square, whole square. So now we want to find these values. So what will be this? So 4 square plus 1, 16, 17. Then we have 4 square plus 3 square. That will be 16 plus 9, 25. Then we have 1 plus 4 minus 7, 3 square, 10. Again 1 and 3 square, so again 10. So now let us sort this. So we have 10, 10, 17, 25. Then we know what our k is 3. So this is good. This was bad and bad. So we choose the top three. So we have two good and one bad. So the classification that the new tissue paper is good is actually true. All right, so the answer is true. So, so this is the calculation that we just did. So here we do the ranking. So, and we can see that 1, 2, 1. So it's one. So these are the three neighbors for our chosen new data set. And among that, we have two good and one bad. So our final answer is the new tissue paper introduced is actually good. All right. So now let's move to k-means clustering. So what is the difference between KNN or k nearest neighbor and k-means clustering? So let's see that. So this problem is clear, right? So if you have any doubt, please do ask. All right, we will move on. So what is k-means clustering? So k-means clustering is an unsupervised machine learning algorithm. So unsupervised means we are not giving any labeled data in this training algorithm. So it's kind of like we are just giving the data and we are doing some task like grouping the data together uh, into say some clusters and all. So what it does is, uh, as the name suggests, k-means clustering, it is used for clustering. So it partitions the data set into k clusters. So k is the number of clusters that we want to get after this algorithm is run. So by using this algorithm, it partitions the data set into k clusters where each data point belongs to the cluster with the nearest mean, or the nearest mean is called as the centroid in this case. So what are some of the applications or problems that can be solved using k-means clustering? So like clustering similar documents, like in previous class, we have seen how classification of documents is done. So different kinds of documents can be classified into different classes for further processing. So k-means clustering can be used for that. Then you can cluster the customers based on features, then market segmentation, and also to identify similar physical groups. So let's see what k-means clustering do. So the overall goal is to divide data into distinct groups such that observed or okay. So what k-means clustering does is, so this is our input data, and what our overall goal, it is to divide the data into distinct groups such that observation within each groups are similar. So if you just look at this data itself, we can see that there are some points clustered here and some another cluster. So we have like around 5 clusters. All right. So how do we know like if we have 5 clusters or more, or if you have less than 5 clusters? What if these two data are similar and these three data were similar? So all those things we will see, but usually the k-means algorithm, it will take care of how many clusters the data can be split into. So in this case, it has been split into 5 clusters as shown here. So one criteria that can be used or that the algorithm follows is minimize intra-cluster distance and maximize inter-cluster distance. So intra means within cluster distance we have to minimize. And let's say now for this data set, the centroid might be somewhere here, or this one it will be here. So we have similarly for each cluster we have. So what the algorithm does is it will minimize the intra cluster, that is within cluster distance, and it will try to maximize these distances, that is uh, between the clusters the distance has to be maximized. So that is the main mm, idea behind the k-means cluster. All right, so these are the steps that we have. So we have to choose a number of clusters. We can specify that. So so if you know, like so we have collected some 5 classes of data, and we need to just to classify those data into 5 clusters. Then we already know the number k, so that can be given. Then what we can do is we will initialize. So if you have chosen 5, um, we will randomly pick this 5 points or k points as initial cluster centers. Then until the cluster stops changing, we have to repeat these 2 steps. Like for each cluster, compute the cluster centroid by taking the mean vector of the points in the cluster. So let's say so let's say we have some data here, then we have data here, and we have some data here. So initially what we have done is so let's say we have 3 clusters. So we have some data. So what we do is we will just initialize 3 points. So let's say we initialize 1 point here, and 1 point, let's say here, and 1 point here. So this will calculate the distance between all points and choose the minimum distance. So initially it will have this number of points. Similarly, this one will have points, and this one will also have points. 3 centroids will have their own points. Then we'll assign these to the closest centroid. So assign each point to the nearest centroid using the distance function. So usually we will be using Euclidean distance. Then in the update step, we will compute new centroid as the mean of points of each clusters. So once this is done, so once these points are clustered or assigned to this centroid, now we'll take the mean of whatever points inside this cluster, and we'll move the centroid. And again, we will repeat the step so that we'll have more number of points. So this will also will move. So in this case, we have only points here. So this will move more towards this, and we'll have new points. So this step is repeated further until the centroid does not change much or a maximum number of iterations are reached. So either of the 2 stopping mechanism you can adopt. So this is steps. So I'll show one of the example with the steps involved in um, um, the steps involved in k-means clustering. So initially this is our data. So in the step 1, we'll randomly assign uh, the classes. Then we initialize the point. So what was our step 1? Randomly assign each point to a cluster. Then we will calculate the mean or centroid. Then after first iteration, we'll calculate the nearest point and move the centroid. So finally, we are going to get something like this. So centroid will be moved to each of the clusters. Now comes the choosing the k value. So the initial data that we have seen. So if k value was 2, so this is for k value 2, we have 2 clusters. Then if we move to 3, we have 4, this was the 5 clusters we have shown before also. Similarly, we move to 6, 1, 2, 3, 7, then we have 8, 1, 2, 3, 4, 8 clusters and 9 clusters. So what is the ideal number of k? So how it is chosen? So that we'll see next. So even though these are all, even though the increasing number of k will give number of clusters according to the chosen value, it is not always ideal option to follow. So the actual case is there is no easy answer for choosing the best k value, because if the data is some data that we got from somewhere and we don't know what how many number of clusters are there in real, so like we also cannot set the k priori. So one way to choose k is the elbow method. So what elbow method does is, first of all, we have to compute the sum of squares of error for different k values. So let's say we choose different k values, k is equal to 4, 6, 8, and we choose we calculate the sum of errors. Then in this case, the sum of errors is defined as the sum of squared distance between each member of the cluster and its centroid. So to write it mathematically, so let's say j is equal to, so or I will write SSC is equal to it will be I equal to 1 to k, where k is the number of clusters. Then we have x belongs to that cluster I, and then we have x minus mu I whole square. So what it does is, for each x in cluster I, the centroid is mu I. So we'll calculate the distance xi minus mu I, and we'll square it and add across all the clusters. So this is the SSE. Now, if you plot this SSE, if you plot this SSE against k, we can see that the error decreases as k gets larger. That's for sure, right? So let's say we have 1, 2, 3 data points. Let's say you have 3 data points, and if we choose only one centroid, so if we choose one centroid, it will be somewhere here. So if you choose one centroid, the distances are higher. Now we choose, so let's say we choose 2 centroid. So let's say one centroid may be here, and one centroid may be at this point, so that the distance decreases further. Now, if we increase our centroid count to 3, so it's 3 centroids will be the same as where the data points are, so that we get 3 clusters. Now the distances are 0 actually, because there is no difference between x minus mu I will be equal to 0 in all these 3 cases, or for all the 3 clusters. So if we increase the centroid, and if it is equal to, or if we increase further the value of k, the number of clusters, we will surely get low SSE. So the error will decrease on increasing the number of clusters, because when the number of clusters increases, they should be smaller, so distortion is also smaller. But the idea of this elbow method is to choose the k at which the SSE decreases abruptly. So let's see how the plot of k against SSE will look like. Then we will see what is this elbow effect. So this is a graph. So so this is the SSE here, and we have the number of clusters on the x-axis. So if the number of clusters was less or 1, then we had high SSE. Then it decreased when it is maybe 2. Then it increased when 4. Then at 6 it decreased 6. At the 6 we can see it is a SSE is at this level, and at 7 if you see there is no much difference. So this should be 7. So there is no much difference between the SSE. Whereas when we moved from 5 to 6, so this was 5. So when we moved from 5 to 6, the difference was higher. So if you look at this, it can be like if you have a hand, so it's kind of like an elbow. So this kinds of like an elbow. So that's why this is called the elbow effect or elbow method to choose the number of k. So in this method, if you see or for this example or for this data set, the number of k chosen is 6. So as we mentioned already, a good method or a good clustering is such that the intra-class similarity is high. That is the difference between the distance between the centroid and the number of points in the cluster should be less, and the inter-class between class similarity has to be low. Now we have one more method which can be used to understand good clustering. So that is called the Silhouette score. So one was the elbow method that we have already discussed. Then the next one is the Silhouette score. So again, elbow method, we plot the squared error and identify the elbow point. So yeah. So this is again the equation of the elbow method. How to find the SSE. Now let's see the Silhouette score. So Silhouette score is a score which measures how similar a data point is to its own cluster versus other clusters. So let's say if we have two clusters like class A and class B, then if there is a point in class A, then the Silhouette score calculates how this point is good to be in class A compared to class B. So it can range from -1 to 1. So higher the score, better the clustering. So it actually balances the cohesion that is within cluster similarity, and it also gives a good balance of separation between the different classes or different clusters. So let's see the equation for Silhouette score. So let's see. So what B A, so B of X, A of X. So X is the data point that we are considering. So Ax denotes the average distance from X to all other points in the same cluster. So let's say we have a cluster here. So this be the cluster 1, then let's be cluster 2, then we have another cluster let's say cluster 3. So if you have an x point here, then a of x is the distance between this x and all other points in the same cluster and average over it. And so we have ax, then bx is the lowest average distance of x to points in another cluster. So in here, if you see, we have two clusters. So we have 2 and 3. So first we have to find the distance between x and all points from 2 and take the average. So we'll have b of x with respect to 2, then b of x with respect to 3. So b of x with respect to 3 will be the average distance of x between the class 3 points. Now we have b of 2 and b of 3. Then we have to choose b of x such that b of x is the lowest average distance of x to points in another cluster. So in this case, from the figure or from this data, we can see that b of 3 will be considered. Then we have to find the Silhouette score. So Silhouette score is performed in this case by b3 of x minus ax divided by maximum of ax or bx. So in this case, it will be b3 of x. All right. So we can see that from the figure itself, this will be smaller, or a of x will be is less than b of x if the point is in the correct cluster. So now let's say our point or one point is here. So let's say one point is here. It is classified as the cluster number 1. So if this is classified as cluster number 1, we can see that these distances will be higher, or a of x becomes greater than b of x, because the point is misclassified as class 1. So in that case, if you calculate the Silhouette score, that is b of x minus a of x divided by the maximum will be a of x. So a of x. So in this case, if you see, we can see that it will be a negative number, whereas here it is a positive number. So if it is correct classification, we'll get a score greater than 0, or we can say that if the Silhouette score S of x is closer to 1, closer to positive 1, the points is well matched to its own cluster and far from others. Whereas if S of x is negative 1, we have to conclude that the point is likely to be misclassified, or it is in a wrong cluster. Or if it is 0, so let's say we have a point here. So let's say these two are equidistant from this point, then we will finally end up with Sx is equal to 0, which means the point is at the boundary of the two clusters. So it can be either of the two clusters. It's kind of 50-50 chance. All right. So now we calculated how we saw how the Silhouette score is calculated for one point. But usually we have a lot of data points in our cluster. So we have to calculate the Silhouette score for the entire data. And usually a good or excellent clustering. So we will calculate the Sx for, let's say if you have 100 data points, I is equal to Si, Xi, I equal to 1 to 100. Then what we do is sum of Xi, sum of S of Xi divided by 100. So we will get average or mean of the CLOT score. Then if this mean falls between 0.7, let's say 7.1 to 1.0, this is an excellent clustering. Or if it is between 0.51 to 0.7, it's good enough. It's good enough clustering. And if it is, let's say 0.25 to 0.5, and it's still acceptable. So it's a fair clustering. And if it is less than, if the value is less than 0.25, then we can say it's a very poor cluster. So this is the usual numbers that we follow. All right. So compared to elbow method, so let's see. So when we can use elbow method? So elbow method is used when we need a quick way of estimating K. Then it also works well with low dimensional, well separated clusters. It's also efficient for a large data set. Then when we can use CLOT scores. So CLOT scores are useful when clusters overlap or boundaries are very fuzzy because we cannot see a correct boundary. So like we have seen in the KNN, the dogs and hosts, there were some overlap in the data. So in such cases, CLOT score works better. Then it provides more objective criterion, and it handles smaller or complex data sets. But it can be slower, but it can handle smaller or complex data sets. And best practice to follow in k-means clustering is to use the elbow method to narrow down a candidate value of k, and then apply the CLOT scores within that range of optimal k. So using the elbow method, we can see the right. So let's say we can choose the clusters within this interval, and then we can calculate the CLOT score for each of these k. And yeah, then we can combine both methods to ensure efficiency and accuracy. All right, so we have some questions. Please try to answer.
First one, D, grouping similar data points together.
Yeah, no, C or D. Yeah, D. D is the correct answer. And second one.
Sir, is it C?
The C is correct answer, correct option. Actually, B is also correct option.
So D.
Yeah, D is the actual answer. So we have the explanation here. So you can read the explanation. So for the correct answer is B. Yeah.
Excuse me, sir.
Yeah.
Sir, so in
This is
exam
actually
also the exam also the standard of the questions will be similar to what you have been solving in problem solving sessions.
Actually, I'm not very sure about that. I'm not very sure about that. Actually, the problem is we are taking the questions not from the professor or someone who is setting the questions. So we are just setting the questions according to internet from wherever we get. Usually, more maybe by 50% questions you can expect from the problem set you have, right, in the Swayam website?
Yes, sir.
Yeah. 50% question will be from that.
Assignments.
Yeah, assignments kind of. More or less, it will be that. So if you thoroughly look that, that will be enough for you.
Okay, thank you, sir.
Yeah. So yeah, we have one more question, two more questions.
B, to measure the separation between cluster.
Which one?
B, to measure the separation between cluster.
Not exactly.
C, to evaluate the quality of the clustering solution.
Yeah, C is the correct answer. Because it's a metric that shows us if the clustering that we have done is good or bad. And for the second question, we haven't discussed it in class, you can just guess the answer.
A mean is sensitive to outliers.
Which one? A. So the correct answer is A. So here is the explanation. So CLOT score is actually used to evaluate the quality of the cluster. So it actually takes into account both the compactness and separation between higher clusters. All right. So we'll discuss some more problems. So for this, we will use the R Studio. So we'll discuss that later. So first question, fifth question.
A, KNN works only for binary classification problems.
We have said that if there are a lot of classes, we can use KNN already.
Yeah. So it is incorrect because they are saying KNN works only for binary classification.
Yes. So A is the correct answer. Okay. Then the next question.
So is it C, distance between the points at a cluster center?
Yes. Next one.
A, scatter plot.
Which is not useful to determine the optimal number of clusters. What scatter plot? Yes, scatter plot is the correct answer. We haven't discussed dendrograms, but scatter plot is the correct answer. And then we have the next question.
Second one, K means clustering.
Yeah. So these two can be confusing, KNN and K means clustering. So the correct answer is K means clustering. Then we have the next question.
Euclidean distance.
Yes.
Distance between points and a cluster center.
Yes. Okay. And this one.
Explicit
Sir, is it
training
C?
and testing phases are involved by implementing KNN.
Yeah, C is the correct answer. And the last, not last.
So both, is it both A and B?
No, it's not both A and B.
The data is large and has many features.
No, no, no. Sorry. So we have seen that in MSE laws, so Euclidean distance which we are calculating. So what will affect more?
A.
Yeah. So the variables with a higher magnitude will have an effect, like if there are outliers or something, that can cause different clusters to happen. So it's a problem with all the distance-based algorithms. So correct answer is C. And the last question.
The intercluster distance is minimized and the intercluster distance is maximized and intracluster distance is minimized. Second.
Yes, second option is the correct answer. Okay, then now I will. We have one problem left, so we'll use the R Studio. We'll try to use the R Studio to solve that. Right. Just share the screen. So is the screen visible? Can you see the screen?
Yes, sir.
Okay. So this is the first question. So we have a data set. So I'll show you the data set first. So we have data set of a arrest that has happened in US for different crimes like assault, murder, rape, and urban. So we have 50 US states, and so we are planning to use K-means algorithm with the 4 clusters. Okay, so let's see how we are going to do that. So let's first look at the questions. So the first question is, according to the built model, the within cluster sum of squares of each cluster is. So that will automatically give the answer. So these are the steps that we need to follow for that. Then the second question. So second question is, according to the built model, the size of each cluster. So it will show us how many members or how many datas are in each clusters. And then the between cluster sum of squares value we have to print, and the total sum of squares. And finally, okay, so that 4 questions will be solved. So we have, so first we have to set the working directory. So we have our working directory here. So we have to set it using this option, set as working directory. And then we have to load these packages. One is caret and class. And this is our first question. So we have to load our data set. So we are loading the data set. So we have 4 variables, 50 objects. So we can see the data set here also. So we have 50 states and 4 columns we have for different crimes. And yeah. So first we will scale the data. Then we will set the seed. So seed we have to set as 1, 2, 3. So seed, setting seed is like we are initializing to some not to some random location. So if we run this algorithm again, we will get the same answer. Then to use the k-means, so this is the algorithm that has to be chosen. So fit k-means. So DF is the data after we have scaled. Then we have the number of senders is 4. Then each will get 20 number of clusters, 20 number of points for each senders. So if you do that, we run the fit, then we can see the numbers. So fit, so let's see if this was an option. Our first question. Okay, so when we did this, we got the answer 8.3, 11.9, 16.2. So yeah, we got the same answer. So this is the within cluster sum of squares for each cluster. So this is the values of centroid minus each of the elements in the centroid, each of the elements in the cluster, and their squares. Then we can find the, so this we already found. Then size of each cluster. So how many elements or how many groups are, how many data are there in each of the cluster? We have 8, 13, 16, and 13. Then between cluster, the between cluster sum, that is 139. So that will be the distance between centroid of each cluster and distance between the cluster centroids. Then total sum of squares of value. So that is 196. Okay, so you can also try this. I will upload the data as well as the R program. So you can download it and also try. Yeah. So that's it for today. So if you have any doubt, you can ask, or else this is the last class for last year section. And yeah, all the best for your exams. All right. Thank you. Thank you for joining. So if you have any doubt, you can ask now, or we'll end this section today.
Excuse me, sir, could you please show those R slides once again?
Slides or the studio?
The slides.
Okay, slides. Yeah. So yeah.
But like if there is no R, if there is, we cannot use R. How? What is the way of doing this problem?
If you cannot use R, we use
Like in
R,
exam,
right?
there won't be R. Like in exam, there won't be R. No, that's why. Like
No,
we cannot
exams
type
there
that
won't be
code.
R. No, but they might ask you. So let's say in this question, they might ask you some lines, syntax to write, or there will be different syntax as options, and they will ask you to choose the right syntax. So that
Oh,
can
okay,
be
okay.
the problems of those sorts can come. But like different functions in R, all means basic functions and all you should know. So
Yes, sir.
all those things can happen in the questions. So
Okay.
so if like they ask like in using k-means, what is the command to print the between cluster sums? So then you will have to type the whatever is shown here, print fit between SS. So there is I don't know if there is chance, but maybe they can ask.
Okay, sir.
So such a basic commands that like in the earlier we have seen how to read CSV files, and all those commands can be asked. Not sure, but there can be a chance.
Yes, sir.
Okay. So any other questions?
Sir, exam in exam this if I this from the questions from this video section is also the assignment
Which
and
one?
video section.
This TA section questions?
Yeah, TA section also questions from there is the for exam.
No. Usually,
Exam.
whatever in the SWAYAM website, those assignment questions you can study those questions. Mostly the questions will be of that format. There can be repeating questions from that. Yeah.
Okay, sir. Thank you, sir.
All right. Then
Excuse me,
see
sir.
you all. Yeah, please.
Excuse me, sir.
Yeah.
Sir, is there any possibility that we will be having programs also in the exam?
I don't think so. Programs will be asked. Like to program something from scratch, it won't be asked. So, like I said, like some syntaxes can be asked, like MCQs or some short answer questions. You will not be asked to write an entire program and all.
Okay. Means we will get the similar questions which are asked in our assignments.
Yeah. Similar
Okay.
questions.
Okay. Thank you, sir.
Yeah, thank you.
Sir,
Yeah,
will there
please.
be a negative marking?
I don't know about the marking scheme and all. I'm not very sure about that. Actually, it should be mentioned in your SWAYAM website if you see that. I'm not very sure about that. All right, then see you. All the best for your exams. Thank you for joining today. All right.
Thank you so much, sir.
Thank you.
Thank you, sir.
So,
Like, thank
you,
you
sir.
for your time, sir.
Yeah. Thank you.
Thank you, sir.
All right. I will end the meeting now. Thank you.